Hello, in this lesson we're going to take a look at exponents and square roots. We're going to identify the difference between an exponent and a base. We'll find the exponent of a number and then we'll find the square root of numbers. Let's first talk about the key words of this lesson. The base is the number that you see that is the regular size type. It's the first number. So we see in 5 cubed that 5 is our base. The exponent is the little one. It's the raised number. And so what an exponent always means is how many times should you multiply the base by itself. So if you have 5 to the power of 3 or 5 cubed, that means 5 times 5 times 5. It does not mean 5 times 3, which is sometimes a mistake we make with exponents. The language around exponents can change a little bit because it means how many times to use the number in multiplication. For some of our exponents, we really just say it one way, but for others, we have multiple ways. So if we look at 8 as the base and 2 as the exponent, we can call this 8 to the power of 2. We can also call it 8 to the second power, or we can simply call it 8 squared. For numbers that have a 3 as the exponent, you can call it 8 to the power of 3, 8 to the third power, or 8 cubed. But there aren't that many like squared and cubed, so the first two styles, such as 8 to the power of 5 or 8 to the fifth power, that would be our typical way of saying that base and exponent. A question that comes up in math a lot is, what if the exponent is 1 or 0? And you'll see this in future math classes. It's repeated throughout all math. If the exponent is 1, then you actually just have the number itself. So for example, 9 to the power of 1 equals 9, and 12 to the power of 1 would equal 12. So anything to the first power means that you're not really multiplying it by itself more than once. It's just itself. But if the exponent is 0, then you get 1. So another rule is, if you have 9 to the power of 0 or 12 to the power of 0, as soon as we see a 0 power, it actually bumps the number back down to 1. So these are two things that you may want to write down in your notes or put stars beside, because they do come up again and again. Perfect squares are the numbers that work out well, and they're usually the ones that we memorize quite early on when we're learning our multiplication tables. So if we look at the example here, 16 is the perfect square of 4. It's because 4 times 4 is 16. So you can see these very common 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. We typically will know the perfect squares more easily than some of our other multiplication facts. Even some of the higher ones we might memorize, like 10 times 10 is 100, 11 times 11 is 121, and 12 times 12 is 144. We may not know what 12 times 13 is, but the perfect squares somehow stick a little bit better. If we look at our times table, our kind of old school times table, we can find the perfect squares in the middle. So 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and 9 times 9. So those perfect squares make a perfect diagonal line right in the center of our multiplication table. When you're asked to say exponents in words, just keep in mind that you have multiple options and one's not better than the other. So we've got some examples here. 6 to the 0 power, 6 to the first power, and 6 to the second power, or 6 squared. So remember, we have a few different ways that we can express exponents. The opposite of exponents is the square root. So that's where we're going backwards. We're going the other way from the answer down to the factor. So if we look at what we know about exponents, we know that 3 squared is equal to 9. 3 times 3 is 9. So therefore, the square root of 9, if we go back down, the square root of 9 is 3. So we can do this with all sorts of numbers. So we can say, yep, 2 squared is equal to 4. Therefore, the square root of 4 is equal to 2. Well, if you're asked to find the square root of 25, then what you're thinking is what times 5, right? What makes 25? Whoops. And you say, yeah, 5 makes 25. So the square root of 25 is 5. So much of math is learning about inverse, the concept of opposites. It's amazing how many concepts in math rely on looking at the opposite. And so let's remind ourselves of opposite operations. When we're talking about adding, our opposite is to subtract. When we're talking about subtraction, the opposite is addition. When we're asked to multiply, the opposite is to divide. When we're asked to divide, the opposite is to multiply. When we're asked for exponents, the opposite is the square root. And when we're asked the square root, the opposite is the exponent. A lot of times we take for granted our earlier operations, that we just know the opposites. Exponents and square roots can be something that we don't have that much experience with. So we have to continually remind ourselves which is which and what is their opposite. So let's begin with the do together, and we're actually going to do some of the exercise together as well if you'd like to continue the video to the end. So number 1 is to complete the square root chart. So we are looking for we have the perfect squares, we're looking for the factors that make these perfect squares. So we ask ourselves, what makes 1 that multiplies by itself? Well, 1 times 1 makes 1. So the square root of 1 is 1. What makes 4? What with an exponent makes 4? The square root of 4 is 2, because 2 times 2 makes 4. What number multiplied by itself makes 36? 6 times 6 makes 36. So the square root of 36 is 6. And what multiplied by itself makes 49? The square root of 49 is 7, because 7 times 7 makes 49. What we're asked to do with number 2 is we're asked to pull apart these exponents. So you can see in the first example here, 5 to the power of 3, that means 5 times 5 times 5. And if we do 5 times 5 times 5, we get an answer of 125. So let's go back to the beginning and start up top. If we have an exponent of 0, 5 to the 0 power, this means that 5 is not actually being multiplied at all. So this is a rule where we drop the number actually becomes a 1. And so in that column, we just put a 1, and in our final column, we can put a 1. With 5 to the power of 1, any number to the power of 1 just remains as itself. So 5 to the first power is just 5, and so we didn't do any multiplication, so our answer is still just 5. For 5 to the power of 2, or 5 to the second power, or 5 squared, this means 5 times 5. And 5 times 5 gives us a result of 25. Let's keep going over on the right-hand side. 6 squared means 6 times 6. So we're going to have a perfect square here. The answer is 36. 7 squared is 7 times 7. And that's 49. 8 to the second power, or 8 squared, is 8 times 8, which is 64. And 9 squared is 9 times 9, which is 81. So we can see from this chart that we're working mainly on perfect squares, but also reviewing the rules of the 0 power law and the first power law. If you'd like to continue on with me on exercise 1.12, we're going to do some of the questions, not all, and then you can finish up on your own. Number 1, we're completing the square root chart. So we're thinking of the opposite of the square root. We're thinking exponents. What makes 9 when it multiplies by itself? 3 times 3 makes 9. What makes 16 multiplied by itself? 4 times 4 makes 16. What makes 25? 5 squared makes 25. What makes 64? 8 squared makes 64. What makes 81? 9 squared makes 81. And what makes 100? 10 squared. Notice that I don't put 10 squared as my answer. The square root gets down to our principal number. 10 squared makes 100, so my answer is simply 10. I've selected some of question number 2 for us to do together. Some of this requires a little bit of scratch work on the side because the numbers might get too big for us to multiply in our head. But let's start with our little guys. Let's start with our 2's. So 2 squared pulled apart, that means 2 times 2. And 2 times 2 is 4. 2 cubed means 2 times 2 times 2. My pen is acting up. And so 2 times 2 is 4, times 2 more is 8. For 2 to the 4th power, this means 2 times 2 times 2 times 2. So we go step by step. 2 times 2 is 4, times 2 more is 8, and 8 times 2 is 16. Over on the right-hand side, we have 6 to the 0 power. Any number to the 0 power is automatically 1, so there's nothing to multiply, so our answer is 1. But 6 cubed is 6 times 6 times 6. And 6 times 6 is 36, and then we have to multiply another 6. So let's do that on the side. 6 times 6 is 36, carry my 3. 6 times 3 is 18, plus 3 is 216. For our next one, we have 7 squared, which is 7 times 7. That makes 49. And then our last one on this row, 8 cubed, is 8 times 8 times 8. 8 times 8 is 64, and then we'll have to multiply another 8 on. 8 times 4 is 32, carry my 3. 8 times 6 is 48, plus 3 is 51. So we get an answer of 512. With the 10s, we can save ourselves a lot of headache by counting zeros. 10 squared is 10 times 10. Check out how many zeros we have. 1, 2 zeros. 10 times 10 is 100. We have 2 zeros in our answer. 10 cubed is 10 times 10 times 10. How many zeros do you have when you're multiplying? You have 1, 2, 3 zeros. You don't have to do the work on the side. All you have to do is make 3 zeros. 10 to the power of 3 is equal to 1,000. So give those ones a try. You can finish off with your 10s and all the other ones, and that way you'll be all set for your exponents and square roots.